Hello people, so welcome to another video. I'm going to go through some function examples. I feel like this is the best way to explain how functions work and just sort of give you a basic sense on how to go through some problems. So we're going to evaluate the function at point 2. I've already done that, and we're going to find our function properties. This is my most popular function on my channel, as you definitely know. Y equals x squared. I use this function because it's used everywhere and it's really simple. So I plugged in the point 2 and I got 2 squared. My y value was 4 at point 2. So we evaluated the function at point 2. Now we're going to find our function's properties. So if I plug in values from minus infinity to 0, I can see that my values on my y-axis are going to get smaller and smaller and closer to 0. But if I go from 0 to plus infinity, my y values are going to get higher and higher. So this is the point where everything changes. So my function is decreasing from minus infinity to 0, and it's increasing from 0 to plus infinity. Now, how do we find our local minimum and local maximum? Well, we see our function goes through the point 0 and doesn't go below it, so that will be our local minimum. And we always evaluate it, we show its location based on where it's located on the x-axis, never the y-axis. Okay, our local maximum, do we have one? If I expand this function into infinity, we just go like this. We don't have any maximum. Our function goes into infinity, so we don't have one. That means nothing belongs here. This symbol. What next? We're going to find the domain of our function, and this is really the first thing you should be doing. The domain of our function is all our x values. Well, we see that we go from minus infinity to plus infinity, so all real numbers. Now, what is the range of our function? You might think all real numbers, you might not, but the answer is incorrect. So, as we see, our y values are only from 0 to infinity. We cannot go below this point. So, our range is going to be all real numbers that are positive. Let's see, that's a plus sign. Or you could also denote that as from 0 to plus infinity. Now, just to make one thing clear, this means all real numbers without plus or minus infinity, and this means all real numbers and also minus infinity and plus infinity. But that is not important for this video. This is something you really learn at university. So, what other properties of our function can we find? It's definitely not periodic. It does not repeat over a certain interval, and that's really all we need to do for now. Now I'm going to find we're going to find a harder example, which is basically going to involve a different function. It's going to be my function f of x is going to be the square root of x plus 2. Now, before you do anything, we know that if we're speaking about if x belongs to the real numbers and not the complex numbers, then, so it doesn't belong in this domain, then our square root cannot be smaller than 0. That's something we have to bear in mind. So we know that whatever we have underneath here, let's say it's a has to be larger or greater or equal to 0. So x plus 2 needs to be greater or equal to 0. X has to be greater or equal to minus 2. If you plug in the number minus 2, you see that we will have the square root of 0, which is basically 0. If we plugged in minus 3, we'd have minus 1, which we cannot solve in the domain of real numbers. We would have to switch to complex numbers. Now, when is our function increasing and when is it decreasing? We might want to plug in some numbers this time. So if you feel like you can't sketch your function, just plug in numbers. So we know we're limited by our domain, so we're not going to plug in numbers that don't even belong here. We're not going to put x values that are smaller than minus 2. So our function basically goes from minus 2 to plus infinity. And what is going to be our range? What is going to be the range of our function? Well, we can tell that our lowest point is going to be 0. We can't go below that because we're not allowed to plug in any x values that are smaller than minus 2. If we can't get our minus value, we can only really get 0. Sorry, that 0 actually belongs there. So it's a different bracket. From 0 to plus infinity. We put the curly brackets on infinity because we can never get to infinity, but we can come infinitely close or really close to infinity. So our function basically has a local minimum at point 0. It does not have a maximum because the y values just shoot up and go into plus infinity. So we don't have a maximum, we only have a minimum, a local minimum. Now another thing we can do with our function, we can tell when it's decreasing and when it's increasing. So if we just plug in our values, so this is going to be x values, this is going to be the output of our function, the numbers on the y-axis. So if we input minus 2, what do we get? We get 0. If we input minus 1, we get the square root of 1, which is 1. If we input 0, we get the square root of 2. If we input 1, we get the square root of 3. And if we input 2, we get 2. So we can see that our function is only getting larger, is not getting any smaller. So our function is basically increasing from minus 2, sorry, wrong bracket, minus 2 to plus infinity. Again, if we input our x values, we get larger and larger numbers, and this goes into infinity. You can try it with 50. 50 plus 2 is the square root of 52, which is definitely larger than these numbers, and our function is always getting bigger. Now in the previous video I mentioned some stuff about limits. So let's just go through some limit examples. So I feel like you've got a basic idea what a limit is. We're always approaching some number on the number line, and just like a function, when we're approaching our x value, we read basically the limit spits out a number, which is on our y-axis, which is our output. So let's say we have a limit where x is approaching the number 2, and our function is x plus 2. Now, a question we have to ask, is our function continuous at the point 2? Well, if we have a look at our domain is from minus 2 to plus infinity. Therefore, it is definitely continuous at the point 2. So we can evaluate our limits. All we need to do is plug in our value, 2, and the square root of 2 plus 2, which is basically the square root of 4, which is 2 squared is, 2. So our limit at this point is 2. Now you might come across some harder limits. Let's say x is approaching 0. And let's say we have a limit that looks like this. X squared minus 2 minus 4, let's say. X squared minus 4. And below it we have x minus 2. Now, you could just plug in, this is a thing, sometimes you can plug in a number, you don't have to do anything fancy with the limit. If we plugged in 0 squared minus 4 and 0 minus 2, we would get minus 4 over minus 2, which is basically 2, and that would be problem solved. But sometimes we can't do that when we have 0 over 0 or infinity over infinity or just any sort of weird number, or 1 over 0 or any number, let's say a over 0, then in that case we would have to factor our limits. So basically we do some basic algebra. And then we just simplify our expression, x plus 2. We input our value, 0, and we get number 2. There are also other methods on evaluating limits, like L'Hopital's rule and some other sort of some other tricks that you can use on evaluating limits, which I won't come across right now. I won't mention them right now. I'll mention them in another video. And that will be all for today. Please like, comment, share and subscribe. Comment below and have a good day.